Yes, can you all hear me and can you see my screen?
Yes, I can.
Perfect. I'll make a start then. Well, first of all, thank you for everyone that's attending to this session. This is my first session that I'm doing to the community, so I'd love any feedback that you can provide at the end. As introduced, my session is going to be on enterprise app development. Let's get my screen up. So yeah, I'd like to just discuss how I do enterprise development. I work at Capgemini as a lead software engineer. Capgemini are a leading consultancy firm across the globe. And one of the many things that it does is Power Apps and Dynamics development, which I've been working in for the past 4 years. Additionally, I'm also an open source contributor to a number of packages, some of my own, some others. And in my free time, I'm an avid photographer and explorer. I'm also a degree apprentice, so I'm not getting much time to do some of those other hobbies I would like. But if you'd like to reach out, then you can find me at either LinkedIn or GitHub with the handle TD Ashworth. So yeah, if you've got any questions after the session and you want to chat, then yeah, reach out there. I'm more than happy to discuss. So the agenda for the next hour or so will be first explaining what enterprise development at scale means, so kind of setting some context there. And then I'd like to discuss some multi-developer options. So how are you going to work if you've got a significant team of developers? At least the experiences that I've seen over the past 4 years is that it becomes more challenging with the more developers that you have, and generally projects get more complex. After exploring those options, I'm going to cover what the development lifecycle is that I typically use on projects, and then finally we'll have some Q&A at the end. If there are any questions, then please drop them in the chat throughout, and I'll try to address them when they come up. Otherwise, I'll try to cover them at the end. Okay, so first, what do I mean by enterprise development at scale? If you're familiar with the Power Platform, which I imagine most of you are, if you're attending this session, you'll know that you can build very small apps, maybe for a team of 10 or 50 or so, or you could be building apps which are business critical, something that your business is dependent on for its general day-to-day business. So these are typically the Dynamics platform apps, so either be it sales or customer service. These are big apps which are used by a majority of your business. Also, I mean agile practices. So these apps are generally built by a significant team and then maintained by a significant team. It's not just going to be a developer or two. You'll generally go through a process of some business analysts trying to put together some requirements, and then developers building those, and then finally some testers coming along to validate that the business requirements are met. In some cases, you may have some ops people that will manage the deployments and the environments. But in today's modern world, we typically follow DevOps, so therefore the devs are also managing the operations of the environments as well. Next up is high quality solutions. Since these are business critical, we aren't just going to deploy into production whenever we want. And we need to make sure there is strict process in there to ensure that the best practices are followed, that every change that we make is tested and validated before it goes in, both from a deployment perspective. We know Power Apps deployments can be challenging at times, along with the actual features are tested as well. And additionally, we're trying to put into practice regression tests through automated UI tests. So every time you do make a change, does it impact anything else that you've got? Is a small business team that you don't typically work with going to be impacted by a change that another team have asked for? So regression test is a great way of covering that. Next up is reliable deployments. We want to make sure that every deployment that we do is going to go the way that we want it to. A number of my clients I've worked with are working on a 24/7 system. So when we ask for an outage to say we would like to do a deployment, we often have a very short window to do so, and we need to make sure that everything goes through smoothly there. It also means making sure that we remove as many manual steps as possible, because when you're doing a deployment at 1 a.m. in the morning, sometimes you'll forget something if it's not written down beforehand. The next point is versioning and traceability. By this, I mean all of our code and data is version controlled. So if we needed to, we could go back, although that's also challenging with Dataverse solutions, and also traceability. Most of the projects we work on are all within Azure DevOps, so it means we can link builds to code to commits and PRs to the requirements and the bugs that they originate from. So we can see exactly what changes are going in and which release, and you can see if a bug has made it into, or if a bug fix has made it into production, and things like that. The last stage is data management. So it's not just the Dataverse solutions that we source control. If there is any reference data or configuration data that the solution needs to work on, we'll typically manage that in version control as well, and we'll deploy that along with our release. So it's the entire package of our solution and data that we deploy, rather than it just being the solutions and the data separately, or the data managed in a separate format. I've known some projects that go to another level where they've got complete pipelines for their data management. So if they need to put a data fix in, they can do so far quicker than having to deploy the entire solution again and waiting on the next release phase that they can do. So that's what I mean by enterprise development at scale. Hopefully that set the scene for everyone. If we look at the next stage, I want to discuss the different approaches that I've explored in the past on how we can develop in the Power Platform when we're talking about any more than just a few developers, because we end up starting to trample on each other's toes. And it can cause further issues down in environments like test it and worse production. So the first model I'd like to share is a shared development and extract environment. I'll come on to in a few slides what I mean by an extract environment, but in short, we're talking about one environment that everyone works in. So everyone will make the changes on their components they want. This is where your unmanaged solution would sit that you're shipping to production. And while this is very simple, it only uses one environment, so the cost of it is very low. And you don't have to worry about constant deployments in other places because it's just the one environment. It doesn't really scale. If you start getting into teams of, say, 10 developers, or you have 2 different teams working on the same solution, everyone starts to trample on everyone else, and you can't actually get a clean change out of that environment because there's always bound to be some other change that's in progress. So when you extract your solution out, there's going to be some unfinished changes in there. It also means components would have to be checked out, and that's so that you avoid other people working on it. If you're changing a form, say, you want to make sure that no one else is changing it at the same time you are, or worse, a workflow or something like that. Changes can't be extracted out in isolation, and that's because if you've got 2 different developers working on 2 different things, one of them is finished and they need to get that into production, you do an extract of your environment, of your solution. The other change is still going to be in progress, and you don't really want to ship an unfinished change, especially if it's something that the business are already currently using. You're going to get some conflicts there. And yeah, work in progress can affect other developers. That's kind of the same as the other points, that you just need to be careful with what everyone else is doing. And as that team grows, it's more difficult to do so. I imagine everyone is already familiar with this approach. And it'd be interesting to know if this is the approach that you're still doing, and if you would consider switching after looking at these other 3 options. So the next option is an individual development and extract environment. Again, I'll come on to what I mean by extract later, but this scales much better. It means that everyone has their own independent environment to work in. You're not trampling on each other's toes. It means that changes can come out in isolation because, yeah, there's no one else working in your environment. But now you have the whole operations side where you now have to make sure that every environment has the latest version of the latest solution that could be deployed. And that can cause difficulty in managing that. This isn't a particular model that I've experimented with before, mainly because of the cost of having so many environments. It can get difficult when you've got a large team. But it is one that is recommended by Microsoft, and I'll share a resource at the end which you could read through if you're interested. The last problem with this is merge conflicts, because you've now got effectively, well, in this case, 4 different environments or many different environments which are mastering the main solution. If one of those solution changes and the other solution changes as well, a great example is if you're familiar with the solution packager already, the solution.xml file can change very rapidly, and 2 different environments could start to conflict with each other there. The next option is a shared development environment, so very similar to the first case, and we also have a shared single extract environment. By extract environment, I mean the environment that masters the shipped solution. So this is the solution that would eventually get into test as managed and into other environments, pre-production and production. The purpose of separating these 2 environments is that changes can be moved across from dev into extract in isolation, and that's done through a development solution, which is the same as any other unmanaged solution, but it allows changes to be moved from one environment to another, and only a subset of them rather than your entire solution, which could have hundreds of components. So the benefit of this is that it's 2 static environments. So you're not worrying about how many environments you have to manage at once. It's only 2 of them. And it can scale well for environments like GitFlow, if you're familiar with that. And it also means that changes can be extracted in isolation. As I said, you only include in your development solution the components that are changing. So when you extract that solution and import it into extract, only the components that you've changed will get modified in extract. And then when you extract your main solution out, your ship solution, it will only contain those changes. The negative issues with this is that because there is only one extract environment, only one extract can happen at a time. So if you've got lots of developers that are finishing their work and they would like to test it in another environment that's a bit more stable so that testers can go in and have a look, you can only do this one at a time. And if there is an issue with that extract, say you had a missing dependency or there was an issue with it when it was being tested, you have to fix forward, because as soon as that change goes into extract, the only way you can reverse it is by wiping the entire environment and then rebuilding it with another unmanaged solution from source. And that can take its time. Extracts have to happen sequentially. So if you've got 2 developers working on the same area, developer B, which could be dependent on developer A, you need to make sure that they're done in the right order, because otherwise you may get missing dependencies or other issues with one not working after the other. You still have the same problem as the first option I provided, where components have to be checked out. And that's, again, because everyone's working in the same development environment, and therefore you can't be modifying the same components if you're trying to keep changes in isolation. And the same applies, work in progress can affect other developers, so you always need to have constant communication. So this does work for teams of a certain size, but that team need to be in constant communication, because if they're not, then these are when problems will start to occur. And the final issue with this is that there is an additional process that needs to be done here. You have to follow a process of moving changes from one environment to extract before it can be kind of extracted into source control and considered as part of your change. The last option is a further development on this, which is you again have one shared development environment, but this time you have what I'm calling a just-in-time extract environment. And you get all of the benefits of it being simple, that everyone works in one environment, and the benefits that changes can come out in isolation. It means that you can have now multiple different changes going on at once, and those changes can be all tested independently before being then merged into source control. This does provide some of those challenges as before, that components have to be checked out. There is an additional process to spin up environments, although with recent changes in the Power Platform, this is far quicker than it ever was before. And you do have to worry about the 5 GB cost, I think it is, for each environment. But because these are just in time, they're disposable, they can just be removed at any point in time if you needed to bring back storage space. As long as that change still remains in development, you can always rebuild the extract environment and then move the development solution across again. So this works well for different workflows, such as the GitHub flow, if you're familiar with that. And it also enables the concept of shifting left, which means that you can test your change in a new environment, like a CI environment, both from a deployment and a feature point of view, before it ever reaches the master branch, say, or your main branch. And that means that whenever you deploy from the main branch, that it is a healthy change and it's not going to cause any issues because it has been thoroughly tested before it reached there. In the other processes, we would typically extract into a feature branch and then PR directly into the main branch, which means that as soon as it then gets into CI and test, it's not tested yet, and that change could go into production. So this allows you to shift backwards. I'd recommend you read up on shift left if that sounds interesting to you. So that ends this section of the talk where I wanted to discuss those options. Going further, I'll be looking at the two options that we looked at the end. They're very similar, so I'll show you what our development process is for it and how it works for the teams I've worked in. And yeah, we'll go from there and see if there are any questions at the end. Okay, so our development lifecycle starts with, as I say, in Azure DevOps, we'll start with Azure boards and we'll pick up a piece of work from the sprint backlog. So the developer will come in, pick up a new piece of work that they've recently finished, and they'll read through the requirements of it, and then they'll set up a session with the developer and BA to have what's known as a 3 amigos. If you're not familiar with what that is, I'll cover it in a bit. And one of the benefits of this, one of the outputs of this, is to define some BDD scenarios. Again, I'll come on to that in a bit, and we'll then develop those a bit later in the life cycle. So once the conversation's had between the three individuals and they have clarity on what the change is required, the developer will go off and make those changes in the development environment. They'll do so in this grey solution here. That's representing the development solution in this case, and the blue solution in both develop and extract are representing the shipped solution, which is the one that will eventually end up in test and then production. As I said, it's mastered in the extract environment, but it does also reside in the development environment. And the main purpose of that is so that the publisher is used across them, so that you've got consistent publisher there. So once you've developed the change, be it creating a new entity or updating some forms or building a flow to meet a business requirement, the developer will then move into Visual Studio on their local machine, and they're going to write up those BDD scenarios in using a tool called SpecFlow, which I'll come on to later. And this are automated tests, automated UI tests from the perspective of the user, the business user that's using the application. So not everything can be tested in this way, but where possible, we try to have as much coverage, and that's so that we can do regression tests later. So now that the change has been developed and it's also being tested from a UI point of view, and potentially some integration tests as well, and unit tests if there are any code involved, be it a C# plugin or some local JavaScript or changes like that. The change would get moved from develop into extract, and then the components from the developed solution would move into the ship solution. So this is a manual process at the moment, and once they start moving into this extract environment, depending on if you're following model 2 or 3 here, depends on if you're blocking anyone else once this change goes in. Once the new components have moved across, if there are any new ones, if you're just updating an existing one, there's no change there. It also allows you to delete any components if you're using stage for upgrade while you're in the extract environment. That's when you can then finally extract those changes into source control and then raise your PR for the feature branch that you're currently on. And at that stage, it can be built and then validated through tests and to a CI environment for deployment, for example. So that's the end-to-end development lifecycle. I'll now go into what each of these stages typically involves, and we'll cover that in more detail. So first, it's the 3 Amigo session. The point in this is that all 3 parties, the BA who's probably worked with a client, the developer who's going to be making those changes, and the tester who's going to be validating those changes against what the requirements are all understanding of what the change is, what the purpose of it is, and what's required to make that happen. So the business analyst is going to share what the story is, explaining to do what the business function is and what the acceptance criteria are. The developer will say, right, I believe that this is the change that's going to be required. This is the impact that it will have on the system. And then the tester can ensure that the test cases that they've written are going to meet all of the acceptance criteria. This is also the opportunity for the 3 parties to discuss any further acceptance criteria that may have not been considered before, any edge cases and stuff like that. Sometimes this may have to go back to the business to get some more clarification, but once everyone is happy at this point in time, they will then write up some BDD scenarios, and these are just enhancements on top of the acceptance criteria, following the given, when, then format I'll come on to next. So once the requirement is understood by everyone, the developer is going to go off and make their change. Here you can see that this is an example of one of the environments I've worked on before, and there are lots of solutions that are in progress, and these are what we would call development solutions. So they've got the item number from Azure DevOps, so we can trace it back to that. They're using the solution prefix so that we know that it's part of what solution that it's going in under. And these solutions are all unmanaged and will only have a handful of changes in. Again, that's to avoid taking a change across that's unnecessary. During the development process, I'm not going to go into too much detail here because I'm sure we're all familiar with how to develop on the platform. We might be using tools like XRM Toolbox for any local development that's required. There are plenty of tools in there that are very helpful. We'll use Visual Studio Code, typically more for script writing, so web resources. We would use Visual Studio itself for any C# code. That's just got a better experience. We may end up using the Power Apps CLI if we need to generate some new projects, like a plugin assembly or something like that. Also, if we need to do any extracts from the solution, we can use that tool. And we also have Capgemini's data migrator tool. As part of developing the change, if it's some configuration data that's required, we would also extract that into source control at the same time here, so that the change all goes in at once. So now that the change is being developed, we can move on to the automated tests. And these are taking those BDD scenarios that I discussed before. So this is what one would look like if you've not seen it before. You'd first state what the feature is that's being made. And then you may have a few different scenarios in here. In this case, it's just the one, and it follows the steps of given, when, then. So given are preconditions to ensure that you're starting the test in the right point. If you consider this to unit tests, if you're familiar with it, this would be your arrange step in it. And then your when step would be the actual action that you would like to take. So in this case, given when I'm in an app, so in this case, it's the UI test app as a specific user. So this is a role-based scenario. So as a basic user, this could be as a sales representative or as a case manager or something like that. When I open up the sub area of contacts under the organization details area, so that's a navigation step, and I open the record at position 0 on the grid, so the first record that I can see, then, and this is where your asserts come in, I am presented with a contact form for the contact entity. So that's just checking that the right form is presented. You probably have more scenarios here to check that the right fields are available and they're with the right type and they've got the right length. And if there's any show hide logic for whatever reason, then you could also test that as well. To make this process as smooth as possible, we are using Microsoft's Easy Repro library, which is a Selenium add-on to work with the Dynamics platform. And on top of that, we're using Power Apps SpecFlow bindings so that we can work with SpecFlow in a really fluent way. All of these steps are known as actions or targets, and the library, the SpecFlow bindings, provides easy steps for each of these for all of the common stuff that you may need to do in Dynamics. Since the UI is already pretty static, we can develop those steps quite easily. I'd just like to give a shout out to David Robertson, who's got a session later in the day at 5 p.m. To discuss this more. So if you're interested in automated UI tests further, I'd recommend you pop onto his session later today to find out more about this. Okay, so now we've developed the change, we've tested the change. Next, we need to progress that change ready for exporting into the source control that we have. So the process for this is to move your environment, your development solution across first into extract. And once that change is progressed into extract, we can see it only contains those changes that are required. If we look here, we've got a table that we've modified, so maybe a field we've added, let's say, and a flow we've added into this solution. That table already exists in the main solution, in the ship solution, but the flow does not. So the next stage is to move that flow across into the solution so that when we do the extract of it next, we would then also include that flow. And that's the export of both the unmanaged and managed versions of it. And then finally, we'll use the solution packager to unpack those changes into the various XML and JSON files so that it's more source control friendly. When we're in the extract environment, that's where you would also delete any old components. I mentioned that before, and that allows you to keep your solutions quite lean so you don't have leftover changes that aren't required in there anymore. So this is what the manual process would look like. And I've experienced one project where we've trialed this out, and we understood that the process worked quite well. We were able to get far cleaner extracts of the environment or of the solution. So it meant there was never leftover changes that we ever deployed to test or production. But it's quite a manual process, and at one stage there was an individual that was responsible for doing this for other people, and that was obviously not a very fun job to just constantly move solutions through environments and make sure things were all aligned. So someone in our team, Max Ewing, developed another solution, a Dataverse solution called Development Hub, and it will automate all of this process for you. So you would raise something called a solution merge request in the developer environment, and someone in your team will come in and review those changes. And if they're happy with that, it will then progress over to the extract. The point of the solution merge is not just as a trigger for this entire process, but it brings that PR process, which you may be familiar with already, much earlier in the stage, in this development phase. So therefore, if there were any changes that were required, it could be done now rather than you going through this entire process, getting into the PR stage, having to understand all of those files, and then having to go back through the process if there were any changes required. So it just brings that team validation step earlier in the process. Once the team member has approved your change, that's when automatically the solution would be imported into the extract environment. Any changes would be included within it. You would then delete any components, which is a manual step. So you can say, hey, I need to do some manual steps here. So you can pause this extract process, delete any of those components that you may need to, and then it would continue on with the export, unpack, commit, and then pushing that up into source control so that you can raise a PR for it. There'll be a link to this at the end if you would like to look into it further. And I've worked on a few projects that have used this now, and albeit it's in its early days, it's working far better than having a resource do this for us all day, every day. The final stage to this process is to build and deploy it. And for that, we use the CRM package deployer. We rarely deploy solutions as they are, and we prefer using the package deployer for a number of reasons. That's because they can be more repeatable and consistent when we're deploying to an environment, especially when you can consider any manual steps that may be required, making sure that the solutions are in the right order and stuff like that. This tool we can test in a CI environment, in test, in pre-production, and then we've got a lot of confidence that when you go into production, it's going to go smoothly. The tool, if you haven't used it already, is quite configurable with adding in solutions and data files, but it's also extendable. So if you would like to add in some of your own code during this process, then you can do. And it's also transportable. We typically use it in an Azure DevOps pipeline, but if you wanted to run it on a GitHub Actions or on a different CI platform, or even locally, if you had separate environments, if you had clear separation for environments for security reasons or something like that, the package can be moved across quite easily, and all you would do is execute that executable, and it would perform all of the same steps it would if it was in a pipeline. Since the package deployer is configurable and extendable, we built a package on top of it, the package deployer template, which adds in lots of other manual steps that we found that we needed to do. Very early on, it was importing data that we previously exported with the CDS data migrator. While the package deployer already has a data importer function, we didn't find it was rich enough for the data that we were importing. If it was lookup mappings or needing to manipulate the data for the specific environment it was going into, the CDS data migrator was performing a better job of that. So we've included it into the package deployer template. Also, Word templates was a very easy thing to add in very early on in the process. And as the platform has developed further with connection references and environment variables and flows, we've added individual steps for those so that they can be configured for each environment. They pull it in from local environment variables. So if you're using Azure pipelines, that would be your library settings. Sorry, completely forgot the name of them. So it can easily read those and then pull them in for the specific environment you're deploying to. And this removes 90%, if not more, of all the manual steps that we've needed to do for deployments. Just leaving the deployment to run and checking after an hour or two, depending on the size of your solution. And there are no further steps that need to be done, which is really nice. And if a project requires some additional steps for whatever reason to activate or deactivate stuff, then you can add in your own code on top of the package deployer template to ensure that all manual steps are effectively covered, which again improves that repeatability and consistency of your deployment. So once you've built and you've deployed the package, or as part of building and deploy your package, there's the merge PR request, and this is where it differs for your different environments. So if you've got if you're taking the first approach the third approach that I mentioned before, then this would typically be done after you've merged into your main branch. But if you've taken the fourth option where you've got a CI environment spun up, this is what your pipeline may look like. So you'd first build the solution out and you may test it for any unit tests that you've got, be them scripts or plugin code. We'd then also run it via the solution checker to see if there are any compliance issues that Microsoft are reporting on it. And then you would start to provision your CI environment or your extract. In this case, it would be your CI environment. So you would spin up a new environment, you would deploy your solution to it along with any other dependencies. So if you've got a few different solutions you're working with here, this process would also still work with that. You may import some users in there so that those users have access to the environment and can start testing on it. And then you would deploy any of your reference data. Any integration tests could then be run. Your UI acceptance test can be run. And the pipeline will also wait around until someone gives the manual validation to say, yes, I've gone in, I've had a look at the change, I'm happy with it. There are clearly no regression issues that the acceptance tests have picked up. So I'm happy for you to go and then finally delete the environment, which is all automated. And then because the pipeline has succeeded, you can then merge the PR. So there are quite a few steps going on in there. And I've got plenty of time left. So I wanted to give a bonus tip to everyone, which is this process may seem quite difficult to set up with all of the different requirements. And as a consultancy firm, we felt like we were doing this a lot and it was taking up a lot of our own time as we started new projects. So we built a Yeoman generator, which are typically used for JavaScript apps, so web projects. But we found it worked out quite well to template a project which included all of these dependencies for us that could be pre-configured. And then all you need to do is pass in some parameters. So in this case, it's what's the client's name and package. And you can see here on the right that those names get introduced into the into the project that gets generated. There are also different generators within here. So you're looking at the main generator output at the moment. But it will also be able to generate the Azure DevOps project with all of the pipelines for both build and release, any libraries that are required, any extensions it recommends to install. So it can automate this entire process for you, simplifying the beginning of a new project from maybe a week to a day. You can also include new solutions. So if you have a project that has multiple solutions rather than just the one, it can generate more of those solutions for you. If you've got web resource projects, it will scaffold a baseline for that, which includes unit tests. If you are building plugins or some custom workflow activities, it can generate that project for you, again with tests. So that you don't need to configure that as well. It pre-configures it all for you, and it will also do data, again using the CDS data migrator. A recent add-in is also for Power BI projects. So there are some scripts in there which allow you to source control your Power BI project if that's something that your project is currently looking at. I realize I'm quite early. I've got 15 minutes left, but I wanted to open to any questions now. I realize I've covered a lot, so I'd love to hear any of your own thoughts.
Hi, Tom. I think there are some questions on the chat. I'm not sure whether you can see them or you want me to.
Yeah, I can switch over to it. Okay, let me scroll up. Wow, there are lots of comments.
Yeah.
Where do we start? Okay, what do we mean by checked out? So by checked out, there's no kind of official term for it, but this is if you're in a stand up with everyone, you may say, okay, guys, I'm working on this solution or I'm working on this user story at the moment. I need to go in and make some changes to the account form. So everyone needs to be aware that please don't make changes to it. And you may have a formal way of doing this if you would like. In the past, we've renamed components to say like it's being modified, don't change it yet. It's something that you have to work with your team to ensure that no one else tramples on anyone's feet. If you take the account form as an example, if you as developer A were adding a field to it, an existing field to it, then that wouldn't be too bad. If developer B at the same time created a new field, a new column, and added that field into the account form, when you now try to export your change, there'll be a solution dependency on that field that was created. So you just need to be mindful to not include changes which are going to break other people's solutions, and you're going to have to hold off on that until that change is in, which is also important. You need to make sure that changes are small, so therefore they can get into the main branch and unblock other people as quickly as possible. Recently, Microsoft announced that multiple developers can update Power Apps simultaneously with configuration and Git control. Yes, that's true. That is in the space of Canvas apps. It's not something that I have worked with in the past to understand what the experience of that would be. Yeah, I can see Phil's already said something like that, so that's great. It would be good if we could at least extend the co-presence idea. Yeah, agreed. It would be nice if we could see it on other components as well. But we would still need to be mindful that when you try to export your change, you don't want to have impact of anyone else's work unless they were tied together, for example. When importing your components to the extract environment, is it manual or is it via a CI pipeline? So as I explained, we started off in a manual process there, which was quite tedious. But once we had established that the process worked, that's when we built Development Hub, which does use pipelines behind the scenes along with Power Automate flows. So the validation, well, not the validation, the manual steps that you may need to take, that's done by Power Automate approvals. But the pipeline will generally do the import, export, and the solution unpack stage. So yeah, we use a mixture of those. Yeah, thanks, Satya, for dropping the link to Development Hub in there. I've got some resources which I'll put on screen and in the chat. Let me get those up for everyone. Okay, I'll put them in the chat in a bit. I can't select them at the moment. What other questions have we got? Can you talk a little bit how the solutions are structured and how the solutions are layered, segment structured? Yep, good point. So I've worked on a few different versions of solution structuring. One of them was done via components, which is not something I would recommend. So we would typically have a core solution, which would have any of your entities and forms and stuff like that in there. We'd then have a processes solution, which would have any workflows and flows. And then we would have another one for web resources and for plugin assemblies and stuff like that. While that does allow you to break down your solution, so if you only need to deploy a small part of it, it was far quicker. It was difficult to make sure that your solutions were all managed with the right version so that they weren't conflicting with each other when they went into the target environment. So for that reason, I would recommend, from personal experience, to break down your solutions in functional areas. So the more you can break them down, the better it can be. But that's a very challenging conversation to have because there will typically be dependencies across them. Take the account and contact and case entities, for example, will be typically used by several different members or teams within the business. So it's very difficult to say, right, the contact entity is going to be owned by this solution. Everyone's going to be wanting to make changes in there. So yeah, I would recommend breaking it down by functional areas that the solution is trying to target, or the package is trying to target. I wouldn't recommend the component-based approach. And the solution deployer, the package deployer, sorry, can handle multiple solutions and the versions of them and stuff like that. So the two kind of work in parallel, which is quite nice. Can I elaborate on shift left? Yes, sure I can. Are there any other comments? Can you deal with unmanaged solutions on top of flows and Canvas apps in production? So we don't like deploying unmanaged changes to production. For that reason, it can be very difficult to work with that. But in the case where you need a hot fix or something like that, we'll still try to use a managed solution. So if we need to, we can delete that solution later once that change has progressed into the main solutions that we're talking about, the ship solution. A solution layer is created when linking a Canvas app to a prod SQL. I haven't got experience of that to know the impact. The one unmanaged change that we do make, or at least I've been making, is for a custom connector, and we haven't had a problem with that. So we added in a automated step into the package deployer that would set the custom connector base URL, which allows us to obviously target a different endpoint for production and test in comparison to dev, which we were using a mock API for. And that was working fine. We did have an issue a few months ago where it wasn't updating, but other than that, it was fine. So I wouldn't say that there is a big issue with working with unmanaged solutions, but it's something that you do have to experiment with yourself to understand the impacts of that. Going back to the shift left topic, because I think that's an interesting one. As I mentioned during the talk, our process before was to extract a change and get it into the master branch as quickly as possible, the main branch. And that's the branch that we would deploy off. So there would be a pipeline that runs on commit into there. It would rebuild the entire solution, create a build artifact for it, and then the release branch or the release pipelines would use that as the target or use that as the source when deploying to the different target environments. It's a simple approach and it follows the Git workflow quite well. But the challenges of it are it's not a tested solution yet. So you're pushing a change into the main branch without it being tested, be it either a deployment or be it any functional tests that are run on it. So we could have the latest change have a bug in it, and we end up deploying that one to production because it also includes a more recent change where we need to get that one into production for a specific deadline, say. So the best way to tackle this is to do those testing, either functional and from a deployment point of view, earlier in the life cycle before it gets merged into the main branch. And for that, you would build your solution, build your entire package, deploy it to a new environment, so a just-in-time CI environment, say, give the necessary users access to that environment, and then they would be able to go in, the deployment gets tested, the functional change get tested, the regression tests can run on it, and you can be sure that now you can approve and merge that PR, and for it to not impact any other changes that are going on in the main branch. So shift left means that you're bringing that testing process earlier in the life cycle, further left in the life cycle. So it means that your main branch is cleaner and more tested than it would be if you were just kept on pushing into the main branch there. I hope that answers your question. Is there an approach to reduce dependency issues when importing into targets? No, not that I can think of from the top of my head. It's very difficult to manage dependency issues between solutions. I would still say that the functional approach, so splitting up by business area and the functions that they work in, are the best because they will typically have dependencies together. It also means if you make a change to that functional area because they've requested there to be a change, you're only going to be deploying that one solution, rather than if you were to make a change to that one functional area and it impact a entity because it has a new field, a workflow because it now needs that field to be set or read, a web resource because there is some conditional logic that you have on the form, and all of that. That means you're now going to impact 3 or 4 solutions there. So yeah, by functional area is probably the best way to reduce dependencies in my experience. Any tips on ALM when not using Dataverse environments, hence no solutions? Most of the projects that I've worked on are all using solutions, so I don't really have any tips for you there. Some of the projects that my colleagues are working on are now using SharePoint as their main data source, and that's because they're building Canvas apps. I would like to improve the ALM for that, both by migrating data and making sure that the target SharePoint site has the right columns and views and stuff like that. But I haven't had the experience to be able to play around on that yet, but it's something I'd like to play around with in the future. What are your thoughts on having separate environments for hotfixes? It's not something that I've experienced, so it's not. We haven't ever had a separate environment for it. But if you do follow that fourth approach that I shared, you could very easily make that change in dev in your development solution, spin up a quick extract environment to build that into your ship solution, and then switch it over to a CI environment to test that change, and then you could deploy it into production. If your concern was that your solution deployments take too long when going into production, then you could take the unmanaged development solution that you have and layer it on top in production. But it still allows you to test that change before it goes into your production environment. So that would be my recommended approach when it comes to hot fixes. Still test it, of course, but just spin up environment. You've already got the pipelines there, which will build you a new environment, depending on the size of your solution, within a matter of minutes or half an hour or so. So yeah, that would be my approach. Cool. I've got 2 minutes left to spare. I think I'll stop here and give everyone a short break. Thank you very much for listening.
Thank you, Tom. That was an excellent session. Lots of interesting questions. Thank you for sharing your knowledge today. Hopefully we'll see you in future events as well.
Yeah, I'll drop these resources in the chat so that everyone can have a look at them. And if you would like to reach out, yeah, please do so on LinkedIn. Thank you, everyone. Bye.
Thank you. So we continue from here. We've got more sessions coming up. So next is Michael. Michael is an enterprise architect and is going to be talking to us how to enable capabilities for citizen developers so that everyone on the team can